these are the main characteristics of trusted computing. Not trustworthy because we haven't evaluated the trustworthiness, but trusted in a sense because we have this isolated execution environment, and the only way you can access the keys is that you tamper with, that information. Okay. Trusted computing platform, and so we talked about, this is in the form of some built-in hardware. The trusted module is used to create a foundation of trust for the system. So your foundation of trust is not necessarily in the software, but in this hardware component. So that constitutes part of what would be your trusted computing base, along with any other software that you rely on, the basic security functions of it. What's interesting about the trusted computing platform, I think around 2002 or 2001, 2002, most laptops were being shipped with a trusted platform module embedded in the laptop. Now, they were not active, there were no applications to actually use them, but they were actually being embedded in the particular laptop, and just for future use. If we look at the research that's currently being done in the US, it has really lagged behind what has been done in Europe. And most of this has been because researchers have been very suspicious about, what are we going to use this module for? Is industry proposing this so that they can have a way of controlling my system? Do I own the software? Do I own the control of my system? Or is that being controlled by the operating system? So, embracing this technology has lagged behind, in the U.S. The U.S. has lagged behind embracing this technology than Europe. So there's far more research going on, with the use of this technology in Europe as opposed to the U.S. And it's just because of that issue. And I think Richard Stallings has a quote about, trusted computing not being trusted or trustworthy, but treacherous because it could be used to control a system. And it's not very easy to actually use this to try to do something like force you to run a specific software stack before your system boots. And I think that was the scare of, how this technology could be used. So there's been this lag. Although the trusted platform modules have been available in your laptops and home computing devices, for a while. So your home machines and most oftentimes that's where you'll find them, in your large gaming machines that are being, designed for home use. And so it's very understandable why people are very suspicious of, this technology. Why, why is it actually being put in these devices? But the way I see this, technology is not to be used for the evaluation of home computers, and we'll get into why that is, but just the evaluation of infrastructure that is more static, than your home system. When you look at your software stack for your home system, there's a lot of diversity there. There's a large code base, there are many options for drivers and things like that, and it makes the use of this system, for integrity-based measurements very challenging. So we have about 50% of laptops today have trusted platform modules, and we can expect that there will be 100%. When we look at the applications that utilize the trusted platform module now that are on the market, I think BitLocker is one. To use the TPM to actually encrypt your hard drive. And so that's the only one that I can think of, how it's actually being used today. Okay, so we talked about a trusted computing platform and what it is. I introduced the term trusted platform module and talked about how these are stored in your laptops. But actually what a trusted platform module is, it's a chip that has its own CPU. It has some specific cryptographic functions like does SHA-1 hashing, key generation, and RSA encryption. So before I talked about, I have this remote system and I want to measure its integrity. So what an integrity measurement is basically a hash of each file that's loaded, as into memory as part of your software stack. You can also hash any configuration files. Okay, so when it says that when I make a statement and I say that the TPM is measuring my system, basically that measurement is being initiated by your BIOS, your basic input-output system, and it measures itself, and then it loads the next piece of software and it measures it. So what you get is that from the BIOS on up to your applications, each layer is actually measuring the next thing. That information and measurement is basically just taking a hash of the executable or asking the TPM, hey, hash this for me. The TPM then stores that in one of its platform configuration registers. So in addition to having a CPU, some specific functions that are implemented, you have these platform configuration registers that act as storage, where it's the length of a SHA, of the output of a SHA-1 hash, which is 20 bytes. So basically you use that to store your measurements. Now when, the proof comes in, and when we talked about behavioral trust, basically you proving that you have a certain, running a certain software stack is basically having the TPM sign these measurements and then send them off. So a remote request will come into a host and says, give me a quote of what's running. The host has to ask the TPM to basically sign these measurements and then give it to it, and they'll pass it out. Because the signature is not forgeable, then the remote entity knows that this information has come from this particular TPM. So that's how it works. So it's not like the TPM has any control over your system at all. Your booting policy is just based on what you decide to boot. Now, you can lock down some specific files on your system so that you cannot access them unless you're running a specific software stack. So let's say that you've encrypted some files and you've said that I only want to be able to decrypt these files if I'm running this particular configuration. And if I'm not, then my system has been compromised and I don't want to be able to access the system. You can implement those types of things, but that's based on, whatever policy you institute. It's not like the TPM controls your machine. It's basically a tool that can be utilized, to evaluate the integrity of the machine. Okay, are there any questions? All right. Let's see how we're doing on time. We're doing pretty good. So your trusted platform module basically can securely report the environment that it is booted into. It can securely store data, securely identify user and system, because you have a cryptographic identity called an endorsement key that's stored within the TPM, and you can create multiple identities from that trusted identity. So those identities can be stored in encrypted form on the host, while your basically storage root identity is stored within the TPM, and it can be produced inexpensively. So those are some of the design goals and characteristics of the trusted platform module. So we talked about, the TPM being like your root of trust and your foundation of trust. So there are two types of roots of trust within, the trusted computing area. And one is the root of trust for measurement, and there's a root of trust for reporting. Okay. What you will want is that both of those to be embedded within the TPM. Your root of trust for measurement, becomes your, like your BIOS, because it's initiating the measurement. Your root of trust of reporting actually is the TPM itself, because it is responsible for signing and protecting any data. So the signature and the signing is done by the TPM, and it's the entity that's going to be responsible for reporting what your state is. Okay, the host itself forwards the report or the quote from the TPM, but the host cannot construct this, this measurement. Okay. So in a TPM, in a PC, the root of trust for measurement is your entire